sound? That's, we're still coming people inside the room as well, so let's wait. Now I think the sound is on as well. Let's start. So we have some couple of minutes to retake from the previous session. So I'll try to reduce some of my time so we can get a proper break afterwards. But let's talk some about DevOps for front-end engineers. So my name is Mikael, and I've been doing front-end development for a long time now. I see myself mostly as a developer for the full stack, but I think I probably deep down inside identify more as a front-end developer because I've always had some sort of like inferiority complex for backend developers. When I started around 15, 20 years ago doing front-end development, I always heard, you're not doing proper development. You're just doing markup language, which is an entirely different thing. And that's kind of bummed me out because HTML and CSS wasn't proper language, wasn't proper programming. So imagine my surprise now in 2025, the same developers that called my HTML and CSS not as proper programming language is the same people sitting there doing YAML all the times. And I think even the YAML guys making a spec realized this because they renamed YAML from yet another markup language to YAML ain't a markup language, just to try to compensate and see that it's still proper programming. But for some reason, I think DevOps and YAML programming is something that most backend developers, is mostly backend developers that's concerned about this. It's like the hardened backend developer that talks about metrics, talks about infrastructure as CI/CD pipelines. And I think it's no reason it should be like this. But I also think I'm not alone in thinking this, because if we're comparing numbers from like Accelerate and Stack Overflow surveys, we see that from the respondents identifying as DevOps specialists, it's 2 to 3 times as many that's from the backend world as the front-end world. So there's something there that it's not that easy for a front-end developer to identify with DevOps itself. And I think most of it is because of the background, where we're coming from, even now from front-end engineers. So we started with just doing HTML. Publish that, everything's good. And we moved on to making applications, but it's still like just smoshing several modules together and uglifying it, and then we have an application. That's like the baseline for our application, the next step we did in front-end development. For deploying, just choose our favorite FTP program, drag and drop even the file over, and it's deployed. We choose our favorite hosting solution that supported some type of static file hosting, and that's the entire process for doing deployments of applications in front-end world. That's the history. And at some point, front-end was front-end. It was HTML, it was CSS, dynamic HTML, JavaScript on the top of that. So the system was, and the ecosystem was equally simple at that time. But we've gradually moved a lot of different complexities over to the front end. It's not the same type of front end anymore. And we have fragmented the type of definitions we have for front ends. Because one front end isn't created equally. It's different types of front end and different types of complexities, but we have the same term about it. So one type of front end isn't equal to the other types of front end. For instance, an unfinished blog with contents that's older draft and haven't been finished in a year, we call that front-end solution, but we also call a front-end solution the complex web applications like Figma that is also distributed in the same exact manner. So the mechanics and the fundamentals are the same, and we call it the same, but it's vastly different. And I think this fragmentation and the history of how we've done front-end development has contributed to that DevOps is a principle and fundamental principle that's not something we feel ownership to. And I think it's no reason we shouldn't feel ownership to it, and I actually think we absolutely should feel ownership to it, and we should care deeply about it. Because essentially, it's not about infrastructure, it's not about YAML, it's not about tooling. It's about avoiding users sitting there in the rain, calling someone, saying, I can't, this isn't working. And I've had this exact specific, literal experience. So making, when I was part of making bus applications for A to B, I had some of my friends call me standing in the rain because some ticketing purchasing in the app didn't work. And DevOps for me is about reducing that and reducing the issues that is observed in production without having someone to call you. So the goal is for users to have a great experience in your app. And thinking about it from that point of view, we can see that front-end development and DevOps clearly go hand in hand. Because as front-end developers, we do critical systems. We do production critical systems that users care deeply about. We have a complex user-facing type of solutions that we need to care about. And DevOps is about taking ownership for running those processes, making sure they work all the time. And more so, I think actually more than any other solutions, we have the most complex distributed systems because we're running on several devices that we're not having the control over. So DevOps is very much relevant for all types of front-end engineers, even though if you're in the spectrum of making content-driven sites or complex application sites. Well, I like to think about DevOps grouped in 3 different facets. So the production and operational responsibilities, methodology, and philosophy and culture. I think we'll look into all these facets together now and see how it affects us as front-end engineers on a day-to-day basis. So what I'm trying to argue is less like this, a single developer doing a bunch of YAML files, and it's more like a team coming together and improving the way they work. So yeah, DevOps, it's not a backend thing, but it's a software thing, and we're definitely doing software as front-end engineers, more so than ever. So let's look at the production and operational responsibility. And it's important for me here to call it a responsibility, because we know this is something that's been imprinted in us for a long time, right? Our job isn't done when committing code. Our job isn't when understanding code, but it's when the outcome or when the observed wanted effect is there. And that's a continuous thing, because what's working today doesn't mean it's working tomorrow or even in a few seconds. So to be able to make solution that hits our user group, that works the way we intend it, it's not something that we should just control, but we also have to take responsibility for it. And it's not someone else. It's not like there's a team or there's someone doing this. It's you. You have to take responsibility, but luckily it's a plural type of you. So as a team, you have to take responsibility. And this requires us to be familiar and use a lot of different tools and techniques and processes as a part of this. And making it a team effort, I think it's important to think about it as a cultural type of thing. Because there will be issues, there will be conflicts, there will be wavering when doing this. And working on building it as a team culture, organizational culture type of thing, it makes it easier to react when things go sideways. So our gut reaction and how we solve things is something we need to train on, and doing and building culture for this and building a blameless environment allows us to handle situation that goes sideways more naturally. So yeah, things will go wrong. It's not a question of if. And I call it philosophically, or as a part of philosophy, because it's all about the continuous flow. We'll see a bit more, but I'll try to not be too abstract. And also, what do you take if you're trying to build culture and trying to align a specific culture? That's where methodology comes in. So trying to make a framework, trying to make a set of principles to how we work is what builds cultures as well. And it's also an important tool to use to build that culture. And for me, thinking of DevOps as a methodology and a process helps because it's more concrete to explain how we do things the way we do. And according to a survey from Spacelift, 49% of IT organizations asked answered that DevOps was their main preferred way of working as a methodology, as a framework. And over 60% of answered have said that doing DevOps as a methodology, as a framework, improved their deliverables. So if we remember our goal, we were to ensure that there's a working production, ensure that users aren't left in the rain with something that's not working. What does that mean? What do we have to do to ensure that the production is always up and running? And there's many different things we have to do, because if there's something issues, we have to know what and if there's, or when there's issue. So there is some sort of issue. How do we know about that? Is it when someone calls you? No, of course. We want to know before the users know. So we have to see when there is an issue. And when there is an issue, we have to know what the issue is. How do we know that? And we have to know that as quickly as possible. Because again, there will be issues. Either there is bugs, or there is complex issues like misunderstood requirements. Maybe we had an assumption of something working a specific way, and it didn't. So there will be things that are even though we're really trying to do the quality assessments of solutions we deploy, there will be issues. So after we've detected it, after we've seen what the issue is, we have to respond to the issue. We have to fix the issue. We have to deploy on new things. And that we want to do as quickly as possible. So, and we want to be sure that the end users actually observe the fix we have. And hopefully, as a bonus, we should be able to try to prevent similar future issues. And this is what I'm, like, from a philosophical standpoint, thinking as a flow-based development. So we have a continuous flow of fixes and issues and features and whatever flowing out from the developer team through a pipeline over to the user. And we have to observe the effects back again, because how do we know if anything works if we're not observing the actual usage of it? So closing the feedback loop is often called, and it's important to do actual verification and actual quality and to reduce the assumptions we're making. And we want to minimize the time from some requirements are observed to we can solve those requirements for the end users. A subset of that time in DevOps terms is called cycle time. So it's essentially like from a requirement is made to it's observable in production. And there are many ways to improve this. You can just fix the actual time it takes to build something and deploy it. You can make it easier to debug or easier to navigate your code. You can reduce the task or the scope of each task to ensure it's smaller, meaning smaller changes. You can make sure that you never have to do some sort of deploys, but just fix it without doing it. And we have to ensure that no one is blocking us from doing the changes. And we'll look into different aspects of this. Firstly, the CI, continuous integration, continuous development aspects of it. I won't go into too much detail, but this is something in DevOps that has a lot of focus. So because we're automating tools, it feels concrete, it feels good. But still, it's often something maybe the platform team or DevOps engineers or backend developers care mostly about, the CI/CD type of thing. But I think it's really important that front-end engineers takes control and takes responsibility for the CI/CD pipelines as well. We had an example of, it's in the app world, so it's a specialized case in some way, But what's very typical for your app is that it takes a lot of time to build. And we were in a situation where it took 5 hours every time we merged the main, because the build agents for iOS or on Apple is very slow. The build tooling is very slow. And just building it like that, it means that to be able to verify if something actually worked in staging, it took 5 hours. So it's very disruptive for a work. But instead, a colleague on the team tried to look what's the main type of development we do. And we're just switching out, this was a React Native app, so we're just switching out the actual JavaScript bundle so we can do different things of doing that. For instance, doing hot loading or whatever. But we can also just use the entire package as is, the IPA from iOS, reuse that because that hasn't changed, but just the bundle inside. So we're reduced from 5 hours to 5 minutes, just because knowing what the actual tool we're doing. So we can't offset things like doing CI/CD pipelines to others because you have to know like the integral details of what you're actually solving. So leverage caching, doing parallel steps, thinking careful about the critical path of your development pipeline is important, and I think we need, as front-end engineer, to take responsibility for that. The simplest way to reduce cycle time is just to reduce the amount of development time. So just develop less. That's the largest part of that cycle time. But that doesn't mean like work harder or work smarter or whatever. It just work less. So do less and you'll use less time. It's fairly straightforward, I think. But with smaller changes, it also means you can increase the time and output of your flow. So making small changes is key for always being a deployable state as well, because when you reduce the amount of change, you have shorter time that is in flux and your larger time with a stable code base and a deployable state. So this often means like it changes the way we work. Because having larger changes like this, they will be open longer. It's more to take into consideration when doing different type of parallel activities, and it reduces the chance of any like collisions between the code. So it makes you have a lot of temporal state in your code base, and it's hard to do continuous development. So reduce the amount of time you use on every task is critical. And it's hard work because it's not only trying to scope things correctly, but it's structuring and doing planning across the team. And we as developers, we're really like happy to talk about the developer experience of things. Oh, we need developer experience because we need automated testing, we need easier tooling for rolling out things. But again, when we're doing less tasks, there's more coordination, and we have to be, as a team, without feedback. We have to be ready to like collaborate between the different types of activities in our development team. And I like to call this board experience because it's a team effort. We can't just like let one person do the managing of tasks in board. So constantly structure our boards, prime our backlog, and making the tasks and communicating across the entire team is an important part of structuring things to ensure that we are able to do continuous flow. When you have smaller tasks, it's easier to do parallel activities. It's easier to just avoid deploying a specific thing because it's not as important because it's small. And you can easier go around specific thing. Also, what happens when you do a lot of different small changes, it's less ownership per person, per change. So it means like it's more the team's change, not the specific person's change. If you have something that's a change that's lived for 14 days, it's almost like your child. You care for it. This is my change. But a little small change is not as important. And this is important because we have to avoid deployment fear. And this is especially important also like for front-end developers, because if we do no deploys, it means larger change sets, again, higher risk, and causes, again, fear of deploy, which, again, causes no deploys in an internal loop. And it's important to develop your muscle memory for deployment. And this is hard to do. It's easy on paper. It's hard to do in practice. And often, just some weeks ago, a non-technical product owner asked me, they released on Friday at 3. Why would they do that? That's reckless. And he's kind of right, but it's kind of also not right, because it's an issue because you haven't trained the muscle memory of deployment. And if you had that, it would be a less risk, but it's still some risk involved. So it's a tough thing to communicate succinctly to non-technical people. And it's something that also has to be learned for the team and for the organization and for other interests. One way to do this and to keep your code base in a deployable state is to make smaller changes. But what about the unfinished changes? These are established patterns like feature toggling. We can just deploy things. It's not a fact that everything you need to deploy has to be released or has to be observed. It can just be there, mute, existing in the code base and do no harm. And feature toggling is a type of mechanism that can do that. And using feature toggling is important even on front-end development. Yes, it allows us to do things like A/B testing. You can do canary releases. You can do gradual rollouts. But it can also mean that you can do smaller changes. There are other mechanisms too. You can just deploy hidden code that doesn't do anything. It's just there. You can do two-part releases, like just release something, and when it's finished, switch over, and then remove the old part. Again, deploying doesn't mean releasing. So we can do more changes continuously by deploying things without releasing them. So even if you do continuous development, we have mastered the craft of small changes. It's no small feat itself. And even if we are quick to respond to issues, we have to detect when issues occur and find out what actually happened. Because there will be issues. I've said this before. No matter what you do, there will be some type of issues. So when there is a sign of bad weather, we need to understand why. What's happening here? And what's causing this? We see just some sort of error, but where does the error come from? What's the cause? And this is something that's especially hard, like I said, because we're doing the most complex distributed systems there are. We have no control over the devices used. They can be low on hardware. They can be low on battery, poor signals. They can be old software. This is things we don't have any control on, and everything we're distributing is running on the specific devices themselves. So it's hard to understand. There is an issue. What is it? Investing time in doing observability in a good way is worth the effort, but something I feel a lot of front-end engineers skimp out of. So the better observability you have, the easier you can respond to some specific issues. And to be fair, it's hard to do, and it's hard to do correctly. It's hard to do and to bring value. Again, because of this distributed nature of front-end development, I think it's even more important. How many hasn't had like an issue that you know there's an issue, you've seen it in production several times, you can't reproduce it, so even though it occurs sometimes, you just can't fix it. You know there's a bug in my system somewhere, I have no idea where. It happens maybe 2 or 3 times a year. I can't fix it. I can't reproduce it. It's probably lack of observability. So observability, it's the ability to discover what might be wrong. A subpart of this is tracing, where you can see that across the different systems. We have a lot of more modern ways to do tracing nowadays. That's also valuable for frontend. We'll see an example soon. And also doing monitoring, so having predefined metrics to see if anything does occur. As a bonus, also doing alerts. Hey, this happened. Just actually 2 weeks ago, we've done like a form of some time. We weren't supposed to use a lot of time on it, so we didn't do a proper job of doing observability and making metrics and doing alerts. So we had no idea if it actually works. And at some point, we just found, okay, let's add some alerts, because we're tired of being blind, even though we wouldn't want to use a lot of time on it. And suddenly, now like every day, I have alerts of things going wrong. And it didn't work before, but I was like blissfully ignorant. But now, knowing that it actually doesn't work, I have to prioritize and fix it. So that's the strength of doing metrics and observability. This is an example from, I think, Saturday. This is a typical type of error for people using Next. It's just some sort of issue in a promise resolvent, and in a tick of internal mechanisms in Next, it just swallows the error. This is very common to see if you're doing just logs, so just like statements of what happened. And it's very hard to see like what's wrong. It's impossible because the stack trace is nonsensical, the error is nonsensical. It's just an internal error of a tick machine that resolves some issues. But doing tracing properly, we can backtrace and see that this is a symptom of other error. That's API that returned a specific 404 because that person didn't have access to that specific type of thing because he did some he had some impersonation mode of admin, whatever. So it's a non-issue, but it's hard to decipher without the tracing. And this is, again, conceptually easy. It's just adding some sort of tracing on things, but it's harder to do it like to want to, with intention, find issues that's actually used. And in this case, we can also use like callbacks that easier can nest the type of traces. So this is a bad example, actually. But another thing that's important often on the node side of things when doing server-side rendering and whatever is to add things like node auto instrument. So with that, essentially just monkey patches fetch and adds tracing for that. So every time you communicate or do any requests with fetch, it adds tracing for you, and you can see tracing across the different systems automatically and see the type of request that actually goes wrong. OpenTelemetry is it's a quick win to introduce to your system and to use it across your server and your client as well. And also monitoring, I think, is something that's often utilized for front-end systems as well. So we have the concept of core web vitals from Google, for instance. There is just predefined metrics that's used to evaluate the performance of things. It's something that's built into a lot of tools. And to just use that and make, for instance, a Grafana dashboard and adding alerts for that can be valuable. And we'll see how it can be valuable in a while. For people using Next or whatever, you can easily just listen to all of these metrics and push them to whatever collector you want. And the beauty of Grafana is that you can just use reusable dashboards. So you don't have to do it manually, just download the entire dashboard from a different place. And since this is standardized metrics, you can get it like with few clicks. And you can get some sort of insight into how your application in the real world actually works. This is an example of how to set it up using Grafana Alloy and Grafana for visualizations. There are a lot of other different ways to do this. The main advantage of things like OpenTelemetry and the protocol collector protocol now is that it is standardized, so it's easy to use with a lot of different tools. As you see, I've shown it in Application Insights, one of the lesser tools, but it still works. So, but what's even better than to act and detect issues fast? It's to avoid them in the first place. That's the quickest way. And this is something we often call shift-left strategy. So trying to reduce the time it takes by finding what's the issue as soon as possible in your pipeline. So imagine the flow again. The shorter the feedback loop, the easier and the quicker you can fix things. And one way to do shift-left is by testing, automated testing. That's a reason why automated testing is often mentioned as a part of DevOps. So you have like the testing pyramid, right? Unit tests, integration tests, and the holy mighty grail of end-to-end tests that you might have heard at do few tests, but do integration, do end-to-end tests and do good end-to-end tests. So end-to-end tests promise a lot, and it's really, really, really satisfying. And it's really good because you're spinning up the actual solutions, you're trying to observe the actual use of your application. So it's much more realistic testing scenario. But you'll more often than not have very flaky tests, especially on systems that are complex and have authentication as a part of the step. It's really, 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 really hard to do end-to-end tests that are not either it's functioning, or it's a false positive, or it's a false negative, or it's whatever it is. It's very, very flaky. It works and it doesn't work, and it works and it doesn't work. So we end up having to fight a lot more with the actual tests. So it's hard making it work. In the abstract of this, I promised to find a solution to how to make this work like real stable and to work and give value. And I invested a lot of time in this the last year. And my conclusion is that the testing pyramid is a scam. So you should rather focus on the testing open sandwich, which is much more delicious, I think. And also it gets a lot of the value, a lot more stable, and without this false, like, you end up investing so much time in making them work barely, and they work for like 5 minutes in end-to-end tests. But integration test, you can stub out something and have almost the exact same value without the old downsides. There are many ways to shorten the feedback loop in the CI/CD pipeline as well. A couple of months ago, we were to release a website, and I think it was maybe 2 or 3 days before, suddenly I noticed there's something happening here. The site, even on development mode, is beginning to be sluggish. And trying to detect what's actually happened, I saw that for some reason, the bundle size was 11 megabytes. And it was not a WASM type of build or Elm type of build. It was regular front end, but it was 11 megabytes. And we haven't discovered that. So I had to use, I think I used 13 hours of git bisect and trying to step through the entire tree and see where was this introduced. It seems like at some point for a while ago, someone had been accidentally importing the Sanity Studio in a development or in a dependency within a dependency within a dependency. And it's really, really hard finding out. What we should have done earlier was just monitoring our performance continuously, and when doing integration, we see that it automatically that it has some sort of regression on the performance. And we can do that by, for instance, Lighthouse, doing that on merge or on smoke testing, on continuously doing Lighthouse and seeing reporting and adding alerts if the performance suddenly regresses. There are other ways to do this as well. For instance, on accessibility with Pally. Again, it won't catch every accessibility issues you have, but you'll at least secure for the stupid ones. You can do Snike for safety. again, it's not the substitute for doing security, but it's at least catches the obvious ones. So thinking about what we can do to shift left in our pipeline will have an advantage. So ultimately, I think DevOps is for ensuring that the production environment always works, and we have a complex distributed system that is our responsibility. So we have to care about what is actually running for the end users. And to do that, we have to do a lot of things in the code. We have to change the way we work. We have to reduce the amount of changes we do, the size of the changes, and increase the amount. But we have to mitigate and verify to be able to ensure the working production. But ultimately, it's on a human level, because DevOps culture, I think it's people and process and tools. But we have always like focused too much on the tools part of it, and we think that tools isn't as relevant for front-end developers, but it really is. So building a culture, working on the board X, avoiding the blame game, working as a team with ownership across the entire code base, not holding like large feature branches that's mine and mine alone, is the key to ensuring DevOps. So build a culture for responsibility, tighten the feedback loop, do quick, minimal changes, and be ready to act at any time. Optimize for the flow, and don't be afraid. That almost rhymes. Don't be afraid, slam poetry style. Take control of tooling and understand why we automate. I think that's important too. Why do we do things we do? We don't just use tooling, but we want to achieve an effect. Here are some metrics to think about for building culture. Again, you get what you measure, so measuring things can be tricky sometimes, but I think these are safe things to measure. Just to avoid the fear of deploying, just see how many times are you able to deploy, and how long does it take for you to do a cycle time for changes. That's it. So I argue that DevOps is for front-end engineers, but we haven't taken as much ownership of that concept in many cases. But I think it's really, really important. Before I let you go, later today, there's a live podcast from Korsleding. It's in Norwegian, hopefully, maybe. But it's at 19, I think. And we have a QR code we're doing the concept Lørdagsrådet for developers. So if you have an issue you want us and the panel to discuss, send in on this form, and we'll try to help you. You can be anonymous. You can write whatever name you want. So don't be afraid to add a juicy conundrum. Thanks.